Hi, now we're going to talk about the step of modeling your data. So this is part of the iterative process that you will go through as you analyze your data. You may need to introduce more variables here to build your model, depending on what you have found out so far. What do you want to consider? Do you want to consider population density, extent of the lockdown, political affiliation, climate of the area? There's all sorts of things that you may want to introduce and add as variables into your model. And when you determine the factors you want to try, add that data to your data set and then visualize and model and see if your variable has a statistically significant effect. Now, for purposes of our demonstration, we are going to choose a very simple thing that we don't have to add any variables to our data for. So I'm just going to look at right now at a linear model. So a linear model means the variable that I want to look at is predicted by other variables in a linear fashion. So for instance, here I'm going to look at the deaths per thousand being a function of the cases per thousand and see what I get out of that model. So if I look at the summary of that model, I can see that my coefficients and my p-values and so forth. So I can see that basically what this is telling me is that this model would say my deaths per thousand are 0.1589 plus 0.015 times the number of cases per thousand. Okay, so I can just, well, if I want to look at how many cases per thousand are the smallest and how many are the largest. So I can see my cases per thousand go from 2.6 to 131. So I'm going to make a grid from 1 to 151. And I'm going to put that into a table. And I'm calling the variable cases per thousand. And then I am going to, well, I don't need to do that. I can just take my state totals and mutate, adding a new column. The pred is going to be the prediction based off of that model. So forget the stuff I just did. If I needed a grid, I could have done that. Okay, so here I'm going to get, now the prediction is going to be added in as the variable pred. And then if I'd like to see, so once I have looked at that, then I want to make that part of my data set. So let's make a new data set where we call it US total with predictions, okay, where I'm adding those together. So I can look at that and see that I in fact have the deaths per thousand and the predictions. Okay, so now let's take that data set and let's plot both the actuals and the predictions to see how well we're doing. So we will feed that into ggplot, and then we will add in points for both the, let's add points for the real cases. So X is cases per thousand, Y is deaths per thousand, and we'll make those blue. And then let's add in our predictions in red and see how that does. So we can look and see, here is our predictions. See, it's linear. And here were our actuals. Okay, so we can see the model does a reasonably good job of predicting at the lower end and maybe again at the higher end. And in between, it's sort of all over the place. So there are probably other factors that we want to consider as part of the prediction, although clearly cases per thousand is an indicator of the number of deaths per thousand. But why do some places have more cases and fewer deaths and other places have fewer cases for the same number of deaths? Okay, so Modeling, this is just a very simple example of a model that you can do with your data, but this will lead you to other questions, right? Like, what are these points here that have the large residuals? And what's going on in those cases versus the cases that I have already modeled? So this begins the iterative process of then going in and analyzing what's going on with those points. What other variables have I not considered as part of my model that I may want to consider? So this is sort of the cyclical process of the data science analysis. In the next set of videos, we will talk about ways to communicate your results.